So hello students, last time we learned about machine called pulleys. There we saw that in case of there is only one single fixed pulley, there is no mechanical advantage, but in case there is one movable pulley or a compound pulley, we get mechanical advantage of 2. But mechanical advantage of 2 is also very small. For many applications, we require higher mechanical advantage. So, we have to use many pulleys. There are two important arrangements of pulleys by which we can have higher mechanical advantage. One is called combination of pulleys, where we are using n movable pulleys. N is number of movable pulleys, and there is another arrangement called block and tackle system. We will learn both the systems. Now let us start with combination of pulleys. As I told you, in combination of pulleys, we have n number of movable pulleys. In the slide, in this transparency that has been shown to you, you will see that there are 3 movable pulleys and one is a fixed pulley. So, this and these 3 are movable pulleys, but this is a fixed pulley. This pulley is fixed to a rigid support. So, in this diagram, there are 3 numbers of movable pulleys. Now, let us try to understand that how much mechanical advantage we will get and what is the velocity ratio. Now, load is always connected to the bottommost movable pulley as shown in the figure. So, this is my load L that has been connected to this. Now, you will see that in this case, where there are n movable pulleys, there are n number of strings or rope. There is no continuous rope. You can see in this first pulley, this end to this end is a rope. To this pulley, middle pulley, you have got a rope starting from this rigid support and ending at this hook. So always a movable pulley, one end is connected to a rigid support, other end is connected to the bottom of the next movable pulley. So this movable pulley is connected to this bottom of this pulley and other end is connected to the rigid support. And the last movable pulley is connected to the rigid support and other end is passing through a fixed pulley. So the other end which was getting connected to a movable pulley will pass through a fixed pulley, and at the end of the string or rope we will apply our effort. So effort is applied at the string which is passing from the fixed pulley, and load is connected to the bottommost pulley which is movable. Is it all right? So this is the, you can say, construction or how the things are arranged. Now let us try to calculate the mechanical advantage. You have to be very careful to understand. So this is the load L. Now you see this load L is supported by 2 strands, 2 segments, 2 strands, one on left hand side and one on right hand side. Load is connected here, so the 2 strings are holding the load. So as 2 strings are holding the load, if the tension here is T1, first movable pulley, then 2T1 is equal to load L by force equation. So I am getting 2T1 equal to L, or I can say what is my T1? So my T1 is L upon 2. Now this T1 is connected to the bottom of second pulley. So now the similar case will appear here, like here load L was connected, here the tension T1 is connected to the second pulley, and this is balanced by again 2 segments of a string having tension T2. So second pulley, so I have told tension is T2. So 2T2 is equal to T1. So that's what I've written here. 2T2 equal to T1, or if we do algebra, I can say T2 is equal to T1 upon 2. Now to substitute the value of T1 as L upon 2, so I'll get L upon 2 square. So this is my tension in the rope of the second pulley. In the same manner, now this is connected third pulley. So 2T3 would be equal to T2, or I can say T3 is equal to T2 upon 2. And what is T2? I will substitute the value here. I will get L upon T cube. So this is my T3. Now see here. So T2 was L upon T square. T3 is L upon T cube. So if there had been a fourth movable pulley, I would have got T4 equal to L upon 2 raised to 4. So if there are n number of movable pulleys, I will get Tn equal to L upon 2 raised to n. So what I am getting? Now let us go to see here now. So okay, so there are 3 movable pulleys. So I am getting T3, and at T3 I am applying my at T3 I am giving my effort. So to balance this, therefore effort is equal to T3. So I am getting effort equal to T3. So this is very important. Effort you are getting equal to T3. So if effort is T3, then what is mechanical advantage? We know mechanical advantage is L upon E. Isn't it? Mechanical advantage is L upon E. So now let us calculate how much I will get L upon E. So I have got E effort equal to T3. And what is T3? T3 is L upon 2 raised to 3. This is my T3. So now I want L upon E. So to take E there, so I'll get L upon E equal to 2 raised to 3. So I'm getting L upon E as 2 upon 3. So what is L upon E? It is mechanical advantage. Therefore, mechanical advantage is 2 raised to 3, because there are 3 movable pulleys. So in case there are n movable pulleys, I will get mechanical advantage equal to 2 raised to n as written here. So this you should learn. In case there are n number of movable pulleys, then mechanical advantage 2 raised to n. So only you have to be careful in numerical that n has to be number of movable pulleys. Is it all right? So now we will derive how to get velocity ratio. Now as we know, velocity ratio is distance travelled by effort. What is velocity ratio? Distance travelled by effort upon distance travelled by load. So let me raise the load by distance dl. If my load moves by distance dl, then this axle of this pulley will move up by dl. So both these strands of string will move up by distance dl. But I cannot have a loose here. So this string will move a distance 2 into dl. dl of this movement would come here. So this string would move a distance 2 into dl. Now if this is moving 2 into dl, so then second pulley is going up 2 into dl. So again, now both this string will move distance 2 into dl. So this pulley will move a distance 2 into 2 dl. Similarly, third pulley, so this is 2 square dl. So this I can say this is 2 square into dl. Similarly, this pulley, third pulley, will move a distance 2 into distance moved by second pulley, that was 2 square dl. So this will become 2 cube dl. So my third pulley, if is moving a distance 2 into 2 raised to 3 into dl. If this is moving a distance 2 into this free hand is moving a distance of 2 into 2 raised to 3 into dl. So this effort is moving a distance of 2 raised to 3 into dl. So effort is moving 2 raised to 3 into dl, and this one moving dl, and so this dl will cancel. So I'll get velocity ratio of 2 raised to 3 when there are 3 movable pulleys. So if there are n movable pulleys, I will get 2 raised to n. So mechanical advantage is equal to velocity ratio is equal to 2 raised to n. If we take velocity ratio, if we divide by velocity ratio, I will get mechanical advantage upon Vr equal to 2 raised to n about Vr. So this is the, so efficiency is, we have learned last time, na? Efficiency is mechanical advantage upon velocity ratio. So both are same, so answer would be 1 or 100%. Is it all right? So that's what I have written in the explanation. Always there is one fixed pulley and there are others are, n numbers are movable pulleys. So mechanical advantage, I proved to you that mechanical advantage we are getting 2 raised to n, and velocity ratio is also 2 raised to n. So efficiency is 100%. Here I have shown here, this load L is being balanced by tension in these two strings T1 and T2. So 2T1 equal to L, and same thing as I showed you proceeds further, and we get that if there is a 3 pulleys, mechanical advantage is 2 raised to 3, and velocity ratio also we are getting 2 raised to 3 for 3 pulleys, and for n pulleys it will be 2 raised to n. So ideally efficiency would be 100%. But because we are using so many pulleys, so there will be friction in the bearings of the pulleys. Then we are also lifting the movable pulleys, we are also lifting the string, so that will also lower the efficiency. So this is about combination of pulleys. You can revise for few minutes, then we'll proceed further. Now see, in block and tackle system means we have got 2 sets of pulleys, 2 blocks. One is upper block, as you can see, this is an upper block. All pulleys in the upper blocks are in the same frame, they are connected together, and all pulleys in the lower block, they are also connected together in the same frame. So that is why this is called upper block, this is called lower block. Upper block is fixed to a rigid support. Upper block is always fixed to the rigid support. Okay. And lower block carries the load L. So the lower block have connected the load L, and upper block is connected to the rigid support. So in the diagram, there are 2 pulleys in the upper block and 2 pulleys in the lower block. There can be set of 3 and 3, 4 and 4, 5 and 5, or in lower block can have number of pulleys equal to the upper block or one less, but you cannot have in any other fashion. Is it all right? So now you have to listen carefully. It's very important. Whenever upper block and lower block are having same number of pulleys, then I would start passing my rope from the bottom hook of the upper block, as you can see in this diagram from here. I will have to start from here, and so that my string will pass like this, and my effort I will have to apply downwards. If you start from here, then you will not come in this direction, it will go upwards. So whenever number of pulleys in both the blocks are same, start from the bottom hook of the upper block. In case this is having one more, like suppose this is having 3, this is having 2, then you will start from the lower block. You can draw that diagram yourself, it is given in the textbook. Then you have to start from here and do it, you will get it in this block. So this point you have to learn. Now, our purpose is now how to calculate mechanical advantage and velocity ratio of this block and tackle system. Now this case is quite easy. This is the load L. Load L now is supported by 1, 2, 3, 4 strings. Here I am applying the effort. So now in this case there is only one rope or one string that is passing through that. In the previous case, combination of pulleys, number of strings were equal to number of movable pulleys. But in this case, there is only one string. So tension in the full string would remain same, that has been indicated by T. So any in any strand, any portion of the string, the tension would be same, equal to T. So my effort would be equal to tension in the string. If I balance here, so my effort is tension in the string. So I have come to know the effort, and load is L. So now we have to build the relation between load L and effort E, so we will get mechanical advantage. Now this load L is supported by how many strings? 1, 2, 3, 4. This is the same string passing for coming here. This is, so here I am giving effort. So 4 strands of string are supporting load L. Therefore, so load L is being shared by 4. Therefore, each will have L upon 4. So my tension would be L upon 4. In case there are n strings, my tension would have been L upon n. So we should count the number of strings that are supporting the load. So tension is L upon n, and tension is nothing but effort. Therefore, L upon E is equal to n. Therefore, mechanical advantage is equal to n, number of pulleys. So this is the derivation of mechanical advantage of block and tackle system. Even if you have suppose 3 pulleys here, this number of strings will become 5. So whatever are the number of pulleys in block and tackle system, that is the mechanical advantage. Now let us calculate the velocity ratio. Now we will calculate what is VR. See, suppose the load is moving a distance dl. If the load is moving a distance dl, each string 1, 2, 3, 4, each string would move a distance dl. So when each string is moving a distance dl, so all the movement of the strings is done due to the effort being applied. So effort will move distance 4 dl. Therefore, distance moved by effort would be 4 dl. So if the distance moved by effort is 4 dl, This is the distance moved by effort. This is the distance moved here dl. Therefore, velocity ratio is 4 is number of pulleys. Therefore, even in case of block and tackle system, velocity ratio is equal to mechanical advantage is equal to number of pulleys. Therefore, efficiency would be 100%. In case we are considering an ideal condition, but practically we are lifting all this lower block. So we not only lifting this lower L, we are also lifting this. So this will lower the efficiency, and also there will be some friction between in the bearings of the pulleys. Now what I have explained you, I have written it here. As 4 strands are holding the load, the 4T is equal to L. T is equal to L upon 4. So mechanical is 4. And velocity ratio also we are getting 4. Is it alright? You can read this if you want. I will give you 2 minutes for you. Now, let us try to calculate that what would be the efficiency in case we know the weight of the lower block. So, knowing the weight of the lower block as W, we will do the calculation what would be the efficiency now, or what would be the mechanical advantage. As I told you in the last session, that velocity ratio does not change. Mechanical advantage gets reduced. So now, as I explained to you, effort is equal to tension in the spring, tension in the string. So this is my effort. Now mechanical advantage is N of block and tackle system. So weight lifted is not only L but L plus W. W is weight of the lower block. W is weight of the lower block. So this is the weight lifted. So whatever the weight lifted, mechanical advantage is L upon E. Therefore, L is equal to N into E. So total weight lifted is equal to N into E. So total weight lifted is N into E, because mechanical advantage is L upon E, that is N. Okay, mechanical advantage is equal to L upon effort, and mechanical advantage is N. Therefore, L is equal to N into E. What is L? Total weight which I am lifting. Total weight I am lifting is L plus W is equal to NE. So I will get L equal to NE minus W. Simple algebra. Bring W on this side. Now, mechanical advantage is L upon E. So what I will do? I am dividing both the sides, left side and right side. I am dividing by E. So if I divide this by E, I am dividing this also by E. Then this L upon E would give me mechanical advantage. Therefore, mechanical advantage is NE upon E will give me N, and minus W upon E. So this is my mechanical advantage. So velocity ratio will remain as N. Therefore, efficiency is MA upon VR. So this is my mechanical advantage. This, and so you simplify, you will get this. Therefore, my mechanical efficiency gets reduced by W upon NE. So this completes the theory of this chapter. Okay, so we'll end the session here, and in the next session we will do numerical on this topic of machines. Is it alright? So to revise thoroughly, learn the formulae and come next time.